Okay, let's go ahead and look at your graph now. Again, you should be only watching these videos after you've attempted each part of this sample experiment. So the first part that you looked at then was the experimental design and the setup. Now it's time to graph a data table. In order to graph the data table, you have to know what's going on with the data table. As we already said before, the independent variable in this case needs to be the oxygen levels, and that is seen here in the data table where we see the oxygen levels being in the very first column is indicative of it being the independent variable. And then the next columns are all the fish species, and this is going to be their populations. That's kind of a mistake on my part not putting populations here. That's what that should have said. So we have 4 different species that are seen in this data table, and that means that you're going to have 4 different lines. So we're going to have a line for smallmouth bass, largemouth bass, perch, and then crappie. And what we're doing is just graphing oxygen levels and the number of fish species. So the first thing you can do is put in your axis labels. Oxygen levels are going to go on the x-axis since it's the independent variable. Population size will go on the y since it is the dependent variable, which then makes your title population size versus oxygen level. This is a really simple title. Always choose this option. Don't try to make anything fancy. All right. The hard part is the scales, and we did scales a lot. So we need to go ahead and make scales for this grid space. And remember the procedure. So you're going to do first highest minus lowest we'll start with the x-axis. So the highest data point is 600. The lowest is 100. So that would get us to 500. That takes 0 off of our graph since 0 isn't in our data. Step 2 is dividing that difference. So 500 by the number of boxes. So you need to count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we're going to do 500 divided by 10, which gives us 50, and that means each box is going to be worth 50. This is where you would round up if you need to, but 50 is very easy to work with, so there's no reason to round up. And then the third step is to know where to start. So we start our scale at the lowest data point, which is 100. So we start at 100, and then we're going to count by 50s until we get to the end, which gives us a perfect scale of 100 to 600, which is exactly what our data table stretches over. All right, then we need to do that same process for the y-axis. This is where things get a little tricky because you still have to do highest minus lowest for that first step. Now, which column do you pull the highest data point from? Well, you just need to scour it and find the highest data point, which in this case is right here in the perch column. So there's 61, that's the highest, and then subtract from that the lowest. The lowest is in this other smallmouth bass column, which is 1. So you'll do 61 minus 1, which gets you to 60. All right, step 2, divide that difference by the number of boxes. So we have 60 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 boxes. So 60 divided by 10 is 6. And you could round up if you want to, but I can't think of a better number to use. So we'll just go with 6. And you're going to start your scale at the lowest number, which is 1, and count by 6s. So 1, 7, 13, all the way up. And since you used the perfect increment, your scale is also going to be perfect, and it goes from 1 to 61, just like your data does. Once that's over, the hard part is done. Now you're ready to plot points. You're going to plot each of these columns individually from each other, and you're going to use different colors to do so. The colored pencils should be in the room, so just go ahead and use some of those. And then you also need a key. In this case, you need a key because you have multiple lines, and this would be a completed graph. So this is the kind of graph that I would expect to see from you.